Right, so welcome to this session, how to build a nanosat with a BBC microbit. You'll have seen the kits which we're handing out now this morning. We're using the light sensor in this session, so we don't have the cameras on there, so they look a little bit different. But what I want to do is just give you a little bit of background quickly, and then I will show you very briefly exactly how we're going to use the kit, and then the rest of the session is over to you to play with the equipment that we've got, run the experiments, and learn a bit more about how we can use the microbit micro kit to learn about satellites and the atmosphere and all that good stuff. So, my name is Chris Brunskill. I work for a company called the Satellite Applications Catapult. My day-to-day job is to discover new technologies that allow us to build new and innovative new satellites. So, as part of that work, we actually developed our own nanosatellites. This is what I showed off first thing this morning. This includes all of the components you'd find in any normal flight satellite, the sort of ones you see on TV at all times. It's got a payload, which is a camera. It's got some solar panels. It's got a computer. It's got a radio. It's got a power system. And we use this to understand how we can use the latest technology from the ground, as we say, so the stuff that goes into your mobile phones, or indeed that we use with Raspberry Pis or Arduinos, on satellite platforms. And what we wanted to do is find a way of making that as accessible as possible, and that's where we got to the point where we had the interaction with Microsoft over how we might use the microbit and touch develop to augment the microbit with an additional suite of sensors. So that's why we have the satellite microkit, and that is an accessory that plugs into the microbit, and we're going to learn about that today. So the microkit plugs into the microbit, provides data logging capability with a micro SD card. It provides an additional temperature sensor that measures the ambient temperature. We have a camera that we're using for the space race if you're outside at lunch. And it also has the light sensor, which measures in different wavelengths of the spectrum. And that's what we're going to learn about today. So ultraviolet, infrared, and visible light. And that little sensor there, where the sunshine icon is, allows us to measure those different wavelengths under different conditions. So what we want you to get out of this, or we want to get out of this, is to engage with schools. You want to help develop hands-on skills writing code for the microbit. I think you've probably done a lot of that today, so we're going to delve straight into the completed code. You'll get to see how it works, but then we'll use that to program the microbit. We're going to learn about the real-world applications in the activity sheet, and then we'll try out the experiments in a multispectral imaging experiment. Okay, so we'll go to those links in a minute, but I'm going to show you the principles of this first. So what we're going to do is load up a script called the Nano Satellite Challenge Complete, and we will edit that. And what we see here is the microbit development environment has been expanded to include our light sensor. So we can now read the values from the light sensor using a light sensor library. It's called the SI1146. And in this instance, we can read ultraviolet light. And by associating that with a label and with a variable, so UV and UV, then when we click the A button, which is hard for me to see from this angle, then it will give us a reading on the back saying UV, and in this case it's 5. It's not the actual value because you don't have the kit emulated on the website, but that gives you an indication of the value. What we've then added are additional lines here. So now we can read the infrared light and do the same again. When we click the A button, then we get a value for the infrared. And then finally we can do the visible light. Again, press the A button and we get a value. Oh, if I can hit the button. Visible, and again, it will give us some arbitrary number or no number at all. What's this? 1024. There you go. That means something to most people, or some people. So once we've loaded this script and you've taken a look and you understand the principles of how that works, we're going to compile it. That will download. We'll then take your microbit and program that onto the microbit. And copying that onto the microbit, which I guess you can't see, but we copy that onto the microbit, we get a flashing yellow light. You should have seen this all before. As soon as that's copied over, okay. So that's now up and running. You've got USB cables. I'm going to use a battery so that you can all see. So then what we have to do is very carefully attach this to our satellite kit. LEDs facing outwards, that's the important bit. Make sure it is as straight as you can get, and then, oh, not quite. It takes a few attempts, as we found out all today. Pushing it in, there we go. So it goes in perfectly straight and is in completely. Now what that allows us to do is when we hit the reset button, which is on the back here, that should say, fingers crossed, OK. So that means it's now seen the sensor kit on the front that is attached to, and it can use that light sensor in addition to the sensors that are already on the microbit itself. And then what we should be able to do is if we press the OK button, the UV measurement of the back of my hand is 7. And if I've got a torch to hand, which I don't, if I can borrow a torch from someone, here we go, thank you very much. So again, now if I reset that, use my UV torch, I'm not going to shine it in anybody's eyes, but that's a UV light, hold it over the little sunshine sensor there, and you need 3 hands for this, which is why we're grouping you up. Press that, UV is now 48, so 7 to 48. Now that's the first bit. What you'll also find is that on your tables you have some pieces of Perspex. Now these are actually filters. First thing, please do take off the protective sheets. They come off completely on both sides, and what you'll end up with is an opaque one and 2 clear. And on one of those clear filters, you'll see there are some lines marked on the side. That filter filters UV. Looks transparent, but it filters out ultraviolet light. The other transparent one filters nothing. It's completely transparent. Your black one should allow the majority of the infrared light to go through. Clearly, there's no optical light going through. So the purpose of this experiment is to use the lights, to use the filters, and to use the torch to measure the differences in those intensities using the microbit code that we've got here, and try and plot some of those values. We've got an example table in our activity sheet, but I suggest that you use Excel because you can't edit the PDF, unfortunately. So if we just quickly pop back to our presentation. So next step is to go to this URL, buildivo.co.uk/AzureCraft. If you could all get your laptops up and running and start using the loading up that page, what you will see is something that looks like this. And what you'll need to do is click on the Nano Satellite Challenge image, okay? And that will load up a PDF, and that gives you an instruction sheet and some background information. So get the activity sheet down, over to you. If you like, have a play around with that code, see if you can write your own interpretations of it. And the example script is here, /XZF HOT. So that will take you straight to that script. So over to you.